Hey y'all, so I'm going to quickly talk through just the gist of confidence intervals, and we will talk more about this in class. So we're going to talk about how we do a confidence interval and how we interpret it. Those are kind of the two big things. So what is inference? When we take a sample or survey, we are trying to predict what is true about the population. That is the goal always. We want to take what's true for a sample to help us make some kind of estimate or guess about what is true for the population. Because we don't know what's true, we use what's true for our sample as an estimate. And that process is called inference. And there's two main ways that we can do what we call inference. Samples aren't always perfect, right? So if I take a sample of McNeil students and find that in that sample, they spend an average of $24 per week on fast food, does that mean that every sample I take is always going to have an average of $24? Well, no, because we know that there's randomness in our measurement. We know that every sample I take is going to be maybe a little bit different. It's not always going to be perfect. So we use what we call a confidence interval. So one type of inference is called a confidence interval. And what that does is it kind of leaves room for that variability, for that randomness that's going to happen. When we make a prediction, we like to use a window for our prediction. Instead of just predicting one single number that's true for the population, we like to have a little window so that we know, because we know there's randomness and we want to leave room for that. And we call that window the confidence interval. So to calculate a confidence interval, the basic formula is we take a sample statistic. So that just comes, what's the sample data? What is the average from the sample? And then we add and subtract what we call a margin of error. Right? The margin of error, the size of it kind of depends on a couple things. Depends on our sample size, but it also depends on how confident we want to be. The intro video that you watched talked a little bit about how sample size and how confidence level can affect how wide or narrow that interval is. So this is going to be real quick, going back to, if you remember about the empirical rule in chapter 7, right, we learned that 68% of the population data lies within one standard deviation of the mean. 95% of the population data lies within two standard deviations of the mean. 99.7% of the population data falls within three standard deviations of the mean. So where that's coming from is when we do a confidence interval, we often attach a confidence level, right? We say we're 95% confident, or I'm 98% confident, or I'm 80% confident, or I'm 68% confident. And that percentage value is coming from this idea right here, that different percentages of data are found within different ranges of our normal model. So why wouldn't we want to use a 100% confidence interval? Surely I would want to be super, super extra confident. So why couldn't I just use 100%? I'm 100% confident that the true average, whatever, is between these two numbers. Well, the problem with 100% confident is that if I think about it in terms of this, right, 100% of our data is pretty much going to be in an interval that is so wide that it's not helpful anymore. I could say that I'm 100% confident that the average temperature in the US tomorrow will be between negative 80 and positive 120 degrees, but that's not very helpful. I want to know a little bit more specific about that. So being 100% confident is not realistic in real life. So that is why we focus on using kind of more realistic confidence levels. So let's look at an example, and I'm going to show you how we use the website that we're going to use to calculate this confidence interval. So in a recent study, the average weight of a sample of 100 shrews was found to be 5.45 grams. Based on previous data, the standard deviation of weights is thought to be 0.08 grams. So we're going to need those two pieces of information because both of those will help us build a confidence interval. The website we're going to use is this one right here. I will make sure and put the link right now in the Edpuzzle. And it looks something like this when we go here. We're going to calculate a confidence interval, a 95% confidence interval, for the average weight of all shrews based on what we know about the sample. Okay. So I'm going to go to my little website here, and I'm going to type in the things that I know. So the confidence level I want is 95%, so 0.95. The mean or average from the sample they told us was 5.45. So I'm going to type that in. The mean is the average. This little symbol right here, it kind of looks like an O. That is the standard deviation, which they tell us is 0.08. And then N is the sample size. So they took a sample of 100 shrews. A lot of you were asking about what that means. That just means how many people or how many objects or how many shrews in this case were in our sample. So it says they took a sample of 100. So that is our N, which is our sample size. Once I plug all of those numbers in, I get down here a lower limit and an upper limit. So those two numbers are the interval. They also write it in terms of like the center of the interval plus minus. This is the margin of error. But we also are just given a lower and upper limit, and that's what I'm going to use here. So that's what I got from my little website for 5.434 to 5.466. So what does that interval tell us? How can we explain it? When we explain an interval, we like to say that we are, I don't know why we always say we, but we are 95% confident, or we can be 95% confident because that was our confidence level, that the average weight of all shrews, that's what we were trying to estimate, is somewhere between these two numbers. So the average weight of all shrews is somewhere between 5.434 and 5.466 grams, and we're 95% confident that that is true. Right? We're never going to be 100%, so in this case, we're 95%. And what that came from is how much of the graph we were including in that interval. So if we were to draw this on that normal model, we've included the middle 95% of values is where that came from, right? So let's say a shrew expert says that the average weight of shrews is actually 5.5 grams. That's what he said. He thinks he knows. Does our interval support what he said? So he's saying it's 5.5. My interval was from 5.434 to 5.466. So based on my interval, right, the true average is somewhere between these two numbers. We can say, no, my interval does not support that because our interval only goes up to 5.466. He's saying it's 5.5. Our interval does not include 5.5. So we can be pretty confident. We can be 95% confident that the average weight of shrews is not what he says it was. Right, that it's less than that because our interval is less than that. Okay. What if we increase our confidence level to 99%? So let's do that. So let's go over to our little website, and I change my confidence level up here. Instead of 0.95, I'm going to change it to 0.99. Right, and if I click off of it, I see that my interval has changed. It may not have changed a whole lot, but it did change a little bit. It's now 5.429 to 5.47. So if you remember, our previous interval was 5.43, and now it's 5.42. So our lower end of our interval is just a tad smaller. And then our old interval ended at 5.466, and now it's at 5.47. So our upper end of our interval is a little bit higher. So we have now kind of made our interval a tad wider, right? The lower end is a little bit lower. The upper end is a little bit wider or higher. So our interval is just a tad wider. So as confidence level increases, the interval actually gets wider. And where that comes from is if I want to be more confident in my answer, then my interval needs to get a little bit wider to make sure that my true average that I'm trying to estimate is still within that interval. So if I want to be more confident, then my interval needs to get wider. And the opposite is also true. If my confidence level decreases, then my interval is going to get a little bit narrower. What it actually means when we say that we're so much percent confident, what that actually comes from. So confidence intervals, remember, have the form. We take our statistic, which comes from the sample. It's your sample average. And we add and subtract what we call a margin of error. So our confidence, when we say we're 95% confident, that confidence is in the process of creating that interval. It's not necessarily in any one interval. So when we say we're 95% confident, right, then we expect to capture that true average, whatever it is we're trying to estimate, about 95% of the time. So over here, we have kind of an image. It's kind of hard to tell what's happening here, but on the bottom, it says sample number. This just means that I took a whole bunch of samples. So let's say I took one sample, and then this was the interval that I calculated. And then I took another sample, and this was the interval I calculated. Right? That green line that's in the middle represents the true average, whatever I was trying to find. So notice that my interval does not always include the true average. So this one interval right here did not include the true average. Most of them do. Most of my intervals captured that true average, but some of them didn't. So when we say we're 95% confident, we mean that if we were to do this a whole lot of times, about 95% of those intervals would include the true thing we're looking for. So most of the time, our interval is going to give us a really good estimation. Occasionally, it will not. We're not going to be perfect all the time, but most of the time, we will get the right answer within our interval, which is what we need, right? Last thing, in order for this confidence interval to be accurate, we need to know the standard deviation of the population. Right, our population should be roughly normal. And then if they're not, then we need a sample size of at least 30 because that central limit theorem still applies. So those are things that we'll talk about more in class, but I wanted to put those up here for things that need to be true in order for this confidence interval to be accurate.